Welcome! Today, we are digging into the code behind your walls, specifically the rules that dictate how to safely run electrical wiring on the outside of a building.
I think we've all been there. You have this fantastic idea for some string lights in the backyard, or maybe a super handy outlet on the deck, but then you stop and you think, wait, how do I actually run this wire so it's not just going to work, but it's going to be safe from the rain, the sun, and, well, everything else?
Well, the good news is you don't have to guess. It turns out there's this incredibly detailed playbook that all the pros follow. And this isn't about a bunch of random, arbitrary rules. It's a whole system that's been designed from the ground up with one thing in mind: keeping you safe.
And that brings us to the unsung hero of this entire story, the National Electrical Code. This is the rule book. It's what governs pretty much all the electrical work that happens in the United States.
So what is the National Electrical Code, or the NEC as everyone calls it? Well, what's interesting is that it's not actually a federal law. It's a massive, comprehensive standard that's put together by experts. But it's so well respected, so thorough, that almost every city and state in the country has adopted it into their own local laws. It really is the gold standard for electrical safety. Seriously? Every time you plug in your phone, flip on a light switch, or count on your circuit breaker to do its job, you are benefiting from this amazing safety framework laid out in the NEC. It's one of the most important, totally invisible systems that keeps our modern lives running smoothly and safely.
Okay, so let's zoom in from this giant codebook to one very specific section, 225.10. This part deals directly with our original question: how do you run wiring on the outside surface of a building?
And here it is, right from the source. The code is crystal clear. It basically says, yes, you can absolutely run wires on the outside of a building, but, and this is the crucial part, only for circuits up to a certain voltage, and only if you use a very specific list of approved methods. And that voltage limit, it's 1,000 volts. Now, just to put that in perspective, your typical outlet in your house is 120 volts. Your dryer might be 240. So this rule covers pretty much any situation you'd ever run into in a home, and even most businesses. We're talking about managing some serious power here. This is the million-dollar question, isn't it? If you can't just take an extension cord and staple it to the siding, what can you do? The NEC doesn't just say no. It gives you a whole menu of safe, tested solutions. All right, the first major category of solutions is using something called conduit. The easiest way to think about conduit is that it's like a suit of armor or a protective tunnel that you feed your wires through. It's a tough physical barrier that shields them from the world. And the NEC approves a whole bunch of different kinds of conduit. You've got heavy-duty metal pipes for places where they might get bumped or hit, and you've also got flexible plastic types for when you need to snake around a corner. The big idea here is that there's a specific, tested, and approved tool for literally every single job. Now, the code definitely has its own language. I mean, if you've ever walked down the electrical aisle in a home improvement store, you've seen these letters everywhere. Well, now you're in on the secret. EMT is that lightweight metal tubing, RMC is the really heavy-duty stuff, and PVC is that gray plastic pipe you see all the time. But conduit isn't your only option. The NEC also gives the green light to certain types of cables that come with their own protection already built in, plus a few other clever systems for routing wires. Think of these as a kind of two-for-one deal. You get the wire and its protection all in one package. For instance, some of these cables come wrapped in a flexible metal jacket for physical protection. Others have a super tough, waterproof coating that lets you bury them right in the ground. The protection is literally part of the cable itself. The code also covers these larger scale systems like cable trays or wireways. You can think of these as, well, like highways for wires. They're often used in bigger commercial buildings to manage dozens and dozens of cables all at once, keeping them organized and protected.
Okay, I know that was a lot of acronyms and technical terms, but why? Why does this super specific, super prescriptive list even exist? The answer to that question really gets to the core of what electrical safety is all about.
It boils down to this: standardization is safety. By creating one standard list of approved materials, the NEC completely removes all the guesswork. So now the electrician installing it, the inspector checking it, and the company that made it, everybody, is working from the exact same playbook. And that right there is what creates a reliable, safe system for everyone. Think about the difference. When you just guess and use some unapproved material, you have no idea how it's going to hold up.
You're opening the door to fire risk, to electric shock. But when you use a method from the code, you're using a material that has been specifically designed, tested, and rated to be used outdoors. You get predictable, reliable safety every single time. And I mean, the difference is just night and day. The level of safety you get by sticking to the approved methods is incredibly high. The moment you step outside that list, the safety level just plummets. There's really no comparison. And in the end, that's what this is all for. Every single item on that list in section 225.10 is there for a reason. It's been proven to stand up to all the things the outdoors can throw at it. The brutal UV rays from the sun, the constant moisture from rain and snow, and the simple risk of getting bumped into or damaged. It's a list that's built for resilience. So, the code behind your walls, it isn't just a boring set of rules. It's this hidden layer of protection that we all rely on. And it really makes you wonder, doesn't it? What other carefully designed invisible standards are working all around us, from the pipes in our walls to the data on our phones, all quietly making sure our world stays safe and functional?